Hello everyone, myself Professor Rutuja Jadhav, Assistant Professor, Department of Computer Engineering of KK Institute of Engineering Education and Research, Nasik. In this e-lecture series, we are going to discuss the course Theory of Computation, which is the third year engineering course of 2015 pattern, and the topic that we are going to discuss today is the finite automata. So, in computer science, there are certain problems that machine can solve, and there are certain problems that machine cannot solve. And to deal with such type of problems, there are certain abstract models or the computational models designed, like finite automata, push-down automata, and Turing machine. So here we are going to discuss today only the finite automata, overview of the introduction to the finite automata. So before we proceed with the actual content, actual concept, this is the objective. The objective of this lecture is to understand the basic computational model, that is the finite automata. And after completing this lecture, you will be able to design system using the finite automata. So the outcome of the system is to design system. The outcome of the lecture is to design system using finite automata. So let us see what is finite automata. So finite automata is a basic computational model used for solving problems. It consists of finite number of states. The advantage of having finite number of states is that the system can be designed with fixed number of resources. Also, it does not remember the history of entire system, but it just remembers the relevant or the important part of the system. That is, we can say it has the limited memory. So let us see one basic example of turning on and off of the button. So figure shows the simple finite automata modeling the on and off switch. So here in this case, the switch remembers only two states, on state and the off state. And it allows user to give input, that is, it allows user to press the button. So here in this case, the input is nothing but the pressing of the button, which is ultimately going to change its state accordingly. That is, if the switch is in the off state, after pressing of button, it changes into the on state. And if the system is in the on state, after giving the input, that is after pushing the button or pressing the button, the system goes in the off state. So as seen from the example, the states are represented by the circles. So in our example, there are two states, on state and the off state, represented in the circle. Then you can see there is an arc between the two states, and both the arcs are labeled as push. So the arcs are labeled with the input to the system, push in this case. So here you can see there is only one input push, which signifies in whatever the state the system is in, after receiving the push as the input, system goes to the other state. So one of the state in the FA is designated as the initial state or the start state. So that is the start state, means the state in which the system is initially placed. So in our example, we can see off state is the start state and is represented by an arrow pointing to the state. Then there has to be one or more the final state or the accepting state. In our example, we can say on is the final state, and final state is represented by the double circles. Here in this figure you can't see the double circle, but if we consider on as the final state, we have to represent it using the double circles. So this is a simple FA of on and on button, off and on button. Okay. Now let us see the finite state machine and its classification. So finite state machine, that is the finite automata, is broadly classified into two types: finite automata with output and finite automata without output. So finite automata without output is further classified into three types. First one is the DFA, DFA stands for Deterministic Finite Automata. So here the term deterministic states that whatever is the input given to the system, to the current state, the system will be going or transiting only in the one state. So there will be only one unique state for each input. That is what is deterministic finite automata. The next one is NFA, that is non-deterministic finite automata. So it is just the reverse of DFA. In case of non-deterministic, you are not knowing in which state the system will go. That is, on a single input to the current state, the system can transit or go to the one or more number of states. That is what is NFA. Then there is epsilon NFA. So from the name you can make it out. The finite automata can make the transitions even on the epsilon inputs. So on epsilon inputs there will be transitions. So this is about FA without output. So here we have seen that there is no output generated, but there is only an accepting state or the final state. Okay. Then the second type of FA is FA with output. So this automatas will be generating the outputs. So here again this is further classified into two types, Murray machine and the Milli machine. Now what is the difference between the Murray machine and the Milli machine? Both are generating the output. Then what is the difference? In case of Murray machine, the output depends only on the present state of the system. Whereas in case of the Milli machine, the output depends on the present state as well as the input given to the state. So this is the overall classification of the finite state machine, which we will be studying in the coming lectures. Thank you.